All right, folks, welcome on board. Let's go ahead and dive into it. Lecture one of CS 5008, 5009. So, again, in case you don't know, my name is Mike and I'm going to be one of your instructors. And we want to find the course homepage first. So, let's go ahead and do that. So, if you haven't already, or perhaps you have because you're watching this video, just a reminder you can go to Teaching and Data Structures, Algorithms, and their Systems. Click on this link. Please watch the logistics video if you have not already, just to understand how this course works. Let me make this a little bit bigger and zoom in on it just so you know how important it is to understand how things work. And the idea is that you will be watching this video that you're watching now from this module that'll be found in here in Begin Module, or by clicking the video link for that particular module, sometime before our live discussion, which happens at 1:35 to 4 on Thursdays. Okay, and I'll talk about these logistics a couple of times just to make sure everybody's on the same page, because it's a little bit unusual for us to be online, but I think it will benefit us all. Okay, so I'm just going to go now. I did that a little bit quick to module one and click on begin module here, and then dive into the slides here. Okay, and this is what I want to talk about today, our introduction to CS 5008, 5009. So we are ready to go. Okay, and this course is quite the mouthful: data structures, algorithms, and their applications within computer systems. We'll talk about what that means in a moment. So before we begin, though, I'd like to get us a little pre-class warm-up and, take a moment to introduce yourself. Now, there might not be somebody next to you. Some of you are in the classroom. That's okay. But not too close. So go ahead and wave to somebody if they're nearby, or perhaps say hello if you're on the chat with someone on Teams, or we will do this during the live session. But you never know who's going to be the next brilliant pair. Jobs and Woz, Gates Allen, Francis Allen, perhaps. Turing Church, ready? Are you going to be the next great computer systems scientist or algorithms or whatever? Okay, so we'll play a little game where we can see if you can identify those figures when we are live. Okay, so we are recording. Yes, everything's recorded. So these sessions will be recorded. The live sessions where we talk will be recorded. And then you have many, many videos on Canvas, which, if I back out of here just for a moment, this lecture slide series is corresponding to the videos also on Module 1. I recommend watching this one that you're watching first, always the slideshows, and then going to the Canvas to get more in-depth or a different perspective. Sometimes it's myself talking, sometimes it's another instructor like Vito talking. Okay, so back to the course. I'm just going to call this course CS 5008, 5009 because it's a bit of a mouthful. But what are all these things? Well, data structures are our containers for how we store information. Algorithms are how we process the data. And, computer systems are sort of this interface that lets us as humans talk with our machines, whether that's operating system or maybe the electronics, like the hardware. That's sort of how I think about the computer systems. Okay, and we want to peel away some of those different layers that let us talk to different pieces of our machine and really dive in and understand how the magic works. Okay, so that's our overview here for computer systems. Okay, and occasionally you're going to see myself pop in and out of these videos just because I want to have some contact with you. And I want to start out this quote, though: "Only the paranoid survive." And this is by Andy Grove. So I hope you're not too scared, though. Only the paranoid survive. But my take on that wisdom is, but let's try to have some fun here. Okay. So that's just something said from sort of a great computer scientist. Who was Andy Grove? He's somebody I think about a lot when I think about computer systems and who one of the main people is. So Andy Grove, came along with Intel. He is one of the founders of Robert Noyce and Gordon Moore. He was CEO for a long time and really helped grow Silicon Valley out in California to become, the sort of powerhouse it is that we, why Palo Alto and that area is called Silicon Valley. Okay, so some of the smartest engineers that I think of are often computer systems folks because they understand everything from the top to bottom, you know, from the software all the way through the hardware. So they can really leverage different parts. I think that's super important and an exciting thing about this course. So a little bit about me, your instructor. So there I am. I'll come up again to get a more recent picture of me, I guess. But my career really started with this search of how do I make games. So then it came out with, different games because I like to play games, but I really like to mess around with them and change them and, kind of hack a little bit. So that led me to, how do you program and do this sort of things. Then I started writing video games and so on in middle school, and then started writing for a gaming magazine, little tutorials, and really found my passion for teaching then. Went to Ohio State, or the Ohio State for folks. Did some research there, found out you can do research in gaming, which was super cool, and then that led me to medical visualization and then some other things from there. And then eventually someone told me, hey, you can go get a master's and you should do a PhD. I didn't even know what a PhD was at that time. And, that's a whole other story we can have in office hours, perhaps. But just a little bit about me, different places that I've worked. Some of them you might recognize, some of the fun ones with games like PlayStation and Intel and so on. More recently done some consulting work for these guys for ePipeline. So I'm very active still, in a sense, in industry. Worked at some startups, some institutions, some government places, and of course universities, and of course as a Northeastern Husky like you guys. So, worked quite a different few places, and just go back, places where I worked on systems and algorithms everywhere. So it's been a useful skill to have. And I really have worked as sort of a systems programmer or graphics programmer, compiler engineer. Those are some of the titles I've held. And all this stuff's applicable that we're going to learn in this course. Okay, so what is this course? Rough visualization. You're going to take algorithms, sort of a full semester of algorithms in a full semester computer systems course. This course is sort of a thin layer. You're going to get exposed to a lot of different topics with a systems sort of theme to them. And we'll look a little bit deeper into some algorithms to get you ready for these other courses so you can do a bigger dive into each of them. Okay. So again, my goal is to get everyone through the course and not be intimidated. Again, it is a lot of stuff. The logistics, just for how much material there is, might seem a little bit frightening at the start, but I would rather you have all the material in, sort of known locations like this website or the Canvas page, at least to get you started, than to have to sort of search everywhere on the internet to learn some of this stuff. So myself and Vito and some others have worked really hard to put this together. So we hope you'll be ready for, the next courses or just whatever other challenges you have, okay? So, if you have questions and so on, Piazza forum boards will be a resource for you. Okay, so roughly speaking, this course has a few modules, and perhaps it's easier if I just do this. I'm just going to take the screenshot here and plop it in onto the slideshow. This is where we're going to start here, and the topics that we're going to talk about. So there's a whole bunch of them. You can see them how they're sort of laid out here or on the course website. At least on the system side, I'll move it over here, things like computer architecture, concurrency, systems fundamentals, etc. We'll talk about. And then we're going to get into the algorithms of some of these things. What are the fundamental data structures? How do these things work? Okay. So our computer systems magic, well, I hate to break it to you, but there is no magic in computers. Someone had to figure this stuff out. What do the ones and zeros do? And, that's sort of the fun of this course, taking away some of that magic and then really understanding, at least at some level how this machine works and that somebody's put these things together in a logical way and what are the underlying data structures and algorithms that we use. So that's really the goal. Computer science is an art in a way. It's as much as an art as a science, and how you can kind of creatively put these parts together and build this really cool machine. So no more magic. That's one of my themes whenever I teach a computer systems or computer systems like course. We're not going to look at machines anymore and think there's magic going on. So I hate to break it to you. We're going to learn how things really work. It can be magic to everybody else in the world, but not to us. Okay, so here's just a little cartoon for you for fun. Okay, so some of the course goals. I want to go over the syllabus. If you forget, you can Google my name. You can Google the other instructors' names, and it will usually lead one way or the other to a course website. Here we are. So let me go ahead and run through the goals. The description, here's the registrar description that you read, but you're really going to be learning about data structures and algorithms in real-world systems, and have some applied examples in a computer systems domain. That's really the goal here. Okay, and this will give you the foundation for understanding how modern machine works. And then you can do a deeper dive on another course. So I have lots of objectives, primarily related to working in C, building data structures in C, understanding algorithms, some of the applications in networking, making things work together concurrently or in parallel. There's going to be a lot of stuff. And something past students have told me, whether they're master's students or Alliance students or whatever level they might be, is this course tends to be very broad in its scope, in that you're learning lots of things, and that's normal. So again, it moves fast in that sense, but again, we're going to try to give you all the tools we can to understand these things, so that you're ready for the next leg up. Okay, so again, so that's sort of talking about the applied stuff, but we are going to again learn about, how to do recurrences, do some more of the algorithm stuff that you might have some introduction to. Again, with lots of examples, so that you can succeed later on. That's really the goal here. Okay, and most of you are in this bucket here for the prereqs. Just a few notes on being integrable. Following. This is a safe space. Even though we're in an online environment primarily, I want it to be friendly, welcoming. It's okay to help each other. I'm hoping we can have a great culture on Piazza of helping. You can't necessarily give somebody a code snippet, but you could point them to a resource that was helpful, or tell them a neat trick that you learned, or a good tutorial that you found. That's totally fine, and I encourage that. I want us to be working collaboratively, rather than having to worry about some of these other issues here. So we're all friends here, and I don't think we'll have any problems with this group. Okay. Okay, so other things, makeup policy. This is an online course, so we're a little bit flexible in terms of when you can work on stuff. I hope that's to your advantage, but asking for an extension, I can't really do. Just because we have so many students. If you do have a legitimate reason, like you're in a conference, or if there are athletic events going on or whatever, then just let me know. Try to let me know ahead of time. If you have to travel for some particular event or emergency or whatever, just let me know. We'll try to be flexible, but just because you need extra time isn't fair to your classmates. So there's a small 10% penalty that we enforce, and again, we try to be reasonable about that, but just makes it fair to everybody, and kind of helps keep you motivated to move along with the course content. Okay. If there are things that we can do to make things easier or accommodate you, please let us know. Northeastern has some great resources that are always available, as far as whatever you need to make the classroom experience, whether that's online or offline, better. And then WeCare is another excellent resource just for, if you're having any challenges, please do take a look at this link where you can get support. There's an emergency line that you can always call, just whatever you need. Northeastern has some resources that, asking for help is okay to make sure that you succeed. Okay. So, typically, again, folks who are going to do well are going to show up at the regularly scheduled time, at least online, whether you're showing up in person. So let me zoom you up here just for my section. Again, that is here. For Vito, that is here on Thursdays. So just a reminder on that once again. So do show up to those. They will be recorded, but I recommend, being reserving that time to be watching these lectures or participating with your classmates. Okay, so there are, again, other resources if you need. Again, and just a personal anecdote, if you need a mental break or something, I know these classes move fast and you're juggling lots of things and family and work and so on. I did that as a college student and graduate student. Again, you can ask me about those kind of things in office hours, but juggling multiple jobs and paying tuition, I understand how it's stressful. So, do take your wellness seriously if there are, things that uh, need to be taken care of. And that's always a priority. There's always a chance to learn some of this material again. Try to your best to stay on course, but we understand things happen, and that's okay. And then we'll work to get you back on track. Okay, as far as the course goes, grades and stuff will be posted on Canvas. So again, you can log on to the Canvas page, go down to grades. You click on this part here, and you'll see your grades. We have in-class activities. So what are those? Again, in-class activities are, you click here, begin module, scroll down, in-class activity, and there's a little Google form to fill out. This first one's easy. Everybody gets, 1 out of 1 for filling it out. Just, it's a little bit of a survey for us just to learn a little bit about you. So that's one part of your grading, those little in-class activities. Let me scroll back down here. Other parts of your grading, in-class labs, which we'll get to at the very end, getting your lab. If you watch the logistics video, you'll see me get the repository. Exams might have a little like online exam or so. That's what we've done in the past, or so on. So we have some exams sort of scheduled for us, and then assignments are really the bulk here. So you can see a lot of your work is really programming. This is a fairly applied class as opposed to doing lots of exams. And usually for the exam, we'll give you a study guide, and that's just a way to sort of reflect on things as well. Sometimes it's nice to take a moment to step back and sort of collect all the material that you've learned and think about it. Okay. Here's the grading scale. Just some notes. You can read through all the notes. I'm going through it quick. But we'll never make this harder. We'll never make a 99 in A, for example. But we reserve to lower this to maybe a 94 will be an A. We'll see where things fall. Typically we don't have to move things around because people work hard and do well. So that's always fine. If we have unforeseen circumstances, since I'm primarily online, at least on my side for this course, then we'll rearrange as necessary. If there are sort of like snow days or if I get sick or whatever, and we'll figure things out. So again, on the lateness, just a note on that. Your assignments do need to compile. Easy ways to test that is to go into GitHub, make sure they compile and so on. That's sort of it. We have a policy on regrades. So, 1 week after the grade is posted is your chance to challenge the grade, and it could go up or down or whatever. But that's, we have to make sure that we get everything graded within a reasonable time. And since we have such a large class, we can't do lots of regrades for, all the students. Otherwise, it'll overwhelm our staff, and we want to make things reasonable. Occasionally, there may be something to fix, but you have an option to do it within a week. Your grade could get better or worse, so that's a little bit of a risk. But if you're pretty confident that we missed something, then let us know. And please don't ask multiple members of the course staff for regrades. It's kind of gaming the system, and we keep track of it. So don't worry about it. Okay, so just other sort of policy things you can sort of read through here to make sure that things go well. Some of them are less applicable, again, if you're online, right? But I would like to emphasize this last one. Now, we got a big class, and this more applies to students registered in my section, to try to sign up for an office hours at least once where we get to talk one-on-one. Even though I am virtual, then I get to know who you are. You know where my office is. It's on Microsoft Teams or Google Meet or whatever. But it gives you the habit of, coming to ask for help. And this is often, if you're just trying to introduce yourself, it can be as short as a 2-minute meeting where I ask you some questions about what you want to do, what your previous major was or whatever, and how I can help you achieve your goals. So that's really it here. Okay. All right, so that's the logistics. It's worth walking through those once again on the syllabus. Okay. All right, so occasionally we will work in teams, or we will try to do some team activities, and we usually do them randomly. So you might have a buddy or whatever in this class, or a friend you've made, but I want you to make lots of friends. In the real world, you have to work with everybody. So we usually pseudo-randomly generate teams, and we try to do it reasonable with time zones and that kind of stuff in mind for online class. So we'll do our best we can there. So that's why we try to do things randomly, and there will be some teamwork. Okay, so for this course, you need a laptop or a computer, wherever you're working. I don't care what operating system it is. It doesn't matter if you have the latest Mac or an old Mac or whatever. Linux machine, Windows machine, maybe some other operating system. As long as it has an internet connection, you're pretty good to go in this class. So not too much there. For course text, there's a few, these are some of the ones recommended for the system side. I'll go to the website here to show where those are listed. And I've tried to give a reason for where they're useful. So for the algorithms portion, this book's really great, Grokking Algorithms, because it's very visual. So you can search that. And then there's some more free C resources. And there will always, again, be lots of free resources, through the reading section and so on. So you don't need to buy any book. For the algorithm stuff, there's some neat visualizations here. If you want to check some of these out here for visualizing algorithms or data structure visualizations. Again, I think these could be helpful for you. So please check those out. Okay, so my teaching style, again, everyone learns a little bit differently, but this is a very hands-on class. We're going to be building things. We could argue about even if teaching styles exist. That's a whole different discussion. That's something you might know more, depending on your background. But we try to learn by, listening like you are, visually seeing some things, and, kinesthetic learners actually doing stuff. So, the combination of these three, or whichever one we might be more enthusiastic about, will help us learn. I expect folks will have no trouble on this. We never do, but don't be afraid to ask questions. I don't care if you ask something and it's wrong. The worst scenario is we review and I sort of know where everybody's at. So do ask questions. Sometimes you'll even see me pause to write down the question. And I'm never going to randomly call on students because I never liked that in class, virtual or online. So I won't pressure anyone. So feel free to ask questions. Again, we try to make this a pretty calm environment for everybody here. Now, I'll put myself on there when I'm serious. I don't call on people randomly. That'll never happen. Let's see. Fair warning, for this kind of stuff, I do have a lot of text and stuff on these slides. I don't care for the PowerPoint rules because I think these slides are deliverable for you. And I'm going to sort of talk through them and work through them. So you'll have them here. I try to make them detailed because a PowerPoint slide with only a few words on it doesn't really help you when you go to review it later. So I'm going to break all the PowerPoint rules. So you use somebody else's slides. It's a good example of presentations, I guess. Our teaching assistants are listed on the webpage. They're part of the course staff, so we'll welcome them there. For this one, email, post on Piazza, please. I get a lot of emails. This is just a snapshot I get. This is actually a pretty calm day for a faculty. So you can sort of look at the cadence here. This is about 25 to 30 or so emails every 12 hours. So I'm constantly battling email. Piazza does a nice job of sort of batching things together, and I can look at it. And we also have the whole course staff looking at Piazza to answer your questions. So it will get answered faster, and it's less likely to get lost in email. Now, if you have personal, things that don't need to be posted to the course staff, you need to be out for a class session or whatever, those are good things to email me. But if you have general, course related questions, Piazza will get answered faster by myself or someone else. Okay. Okay, so the expectations of this course are that you've taken a programming course, 5001, 5002, or whatever. I can sort of calibrate a little bit about that. One language well enough. In this course, we're going to be using C. C is the sort of industry standard language for systems related topics. So that's what we're going to use. And I know there's lots of other fun languages that you might have heard about, but if you look at job listings here, C and C++ is necessary, and then C and C++ here for this, developer and game engineering. So I'll pull some examples there. Another one, all the way out in Qualcomm, so virtual reality. That sounds pretty cool, but C and C++, but even assembly programming language we need to learn here, okay? So you sort of get the idea. Yeah, some of these are sort of cherry picked, but if you go yourself and look for, job listings with C programming, still super relevant. So that's a skill we're going to learn. Okay, so if you have any questions, comments, or concerns, at this point, you'd probably post them on Piazza or chat with me during the live session. And otherwise, let's dive in. All right, so what is exactly C, though? Let's go ahead and talk about that. Here's what C looks like. Here's the program. And let's actually code up this example live here in the slideshow. So here it is. I'm going to use the Vim text editor. And in some ways, I just want you to see me doing stuff just so you can see what's possible. But let's just call this hello.c. So C files and then C. We're going to include a library. That's the standard io.h. We need a function. Programs usually have a main function. That's the entry point for most programs. It looks for a function called main, so we know where to start, which line. So we'll start at line 3. And let's put out some output. So puts is to put a string onto the output. Okay, and I'm just going to change this up a little bit here, 5008, 5009. That's a shout out to you guys here. Save that file. And then C is a compiled language. So how we run it is we first compile our project. So hello.c, that's the name. And then we need to output the file. The program or executable program is called hello. And then /hello runs that program, which puts out the string hello 5008, 5009. Okay, so just like that, we have our hello.c program here. Okay, so we compiled it here. I did something a little bit different, and it's always good here to match the slides. I guess Clang or GCC, those are two compilers that, again, take this source code. That's this file up here, and then say, hey, compile this into something that the computer understands, and then output it as an executable file called hello. Okay, so that's what's going on here. So Clang, is our compiler. Hello.c is the name of our text source code. That was this guy over here. And then the output, that's a lowercase o, not a 0 or anything, with a dash in front of it. That's called a flag that sort of says, here's a flag, and then the next thing that follows it is sort of a argument to this flag saying, okay, what are we outputting as? And then hello. Okay, and then as for the C code, include is bringing in a library, so a bunch of other commands that someone else wrote that allows us to do standard input output. So stdio, standard input output, and .h are special files. They're called header files that you can think of header as, sort of the top or the head, and sort of collects or has a bunch of functions ready for us to calc, and that's a library. We'll talk more about that. And that puts command prints something to the screen. There's another way to do this with printf. So again, if you're used to Python, the print function, we can also use printf. Hello. This is going to be an awesome semester. I'm going to use a \n to indicate a new line will be printed. Let's go ahead and do that here as well. Save this file. And then I'm going to recompile it. Okay, hello to you guys. This is going to be an awesome semester. Okay, and then finally, well, we have a function here, main. That was our function name, and it needs to return an integer here. That's what's specified here. And so we're going to return in some integer that's a 0 here. And 0 by convention means that we are returning successfully. Okay, so again, C is a compiled language, and we have to go through this compilation process. This is actually going to be an important picture for us that we'll use in the class. For whatever compiler we're using, Clang or GCC, right? That was this tool here, Clang. It actually takes your C file and it goes through this amazing process. We're going to talk about the compilation process, where it sort of pre-processes the file and then it translates it to this assembly language, which we're going to learn about, and then sort of to a what's called an object file, or something that the machine sort of understands. At this point, you're at your ones and zeros. Glues a bunch of stuff together and then spits out a executable program that you can execute. That was that /hello. So eventually we get to this program /hello where we can do something interesting. Okay. So again, here's just a little exercise of what the compiler can do for us. Okay, so let's kind of follow along here. I'm going to close out this source file here in this window. And we can actually get the assembly version of this code. So what's assembly? Well, when we use this $S flag, we get a hello.s file. And this is the assembly language. So it sort of looks like something that we understand, right? We can sort of pick out some of these things. Hello is in here. This is going to be an awesome semester. But the rest of this doesn't look like commands that you've probably seen before, but they can start to make sense. Sub, so maybe that's like a subtract. Move is moving something around. Calling, maybe a function. So we're going to talk about this assembly language, or at least investigate it a little bit, so we understand what this is. In this assembly language, if we notice where it is in the process here, it's just in this pipeline. It's just like when you're doing something step by step by step by step. You do one thing after the other. So taking our C file and converting to assembly is actually some of the magic that's happening behind the scenes here. And then we can actually just take this assembly file, let's use Clang, our compiler, and then output that executable file here. So Clang, our input here, the assembly file, and then output it here as an assembly file. We get the same thing. Okay, so somewhere, we've uncovered a hidden step that our C code's actually getting translated to assembly first. Okay, so that's kind of cool. And, we talk about, there's this other thing, hello.o here. That's an object file. So how do we get that? Clang-C is just going to compile hello.s or .c actually. And then we get a .o file. So I'm going to run NL, which is going to show the lines for us, this program here. And this is what the computer actually understands. And to us, it's just going to look like garbage, but we'll talk a little bit about maybe what some of this stuff means. But again, we can uncover some of these things, the compiler version. But this is really sort of hard for us to understand what's going on right now, but it's a magic step here. And we can actually do another cool thing. There's this tool called objdump. And let me run it, this last example here, on that .o file, though, that we've just created here. Okay, and it gives us something called a symbol table. So we can see all the symbols in our program. Main, that was one of the functions. We use printf, which is another function, in the put string function. We see the source file name. But this is just some executable file here, and I can sort of peek into it. And that's kind of cool. It's a little bit scary, though, because now we can understand a little bit about how reverse engineering works, right? We're starting to, again, sort of peel back the layers of the onion, if you will, to see what's going on inside our machine and programs to execute. And this is how reverse engineering works in your machine. So we're going to learn about some powerful tools like this objdump tool that can sort of uncover what's going on here. So I think that's pretty cool, and a little bit scary. So again, here's a quick view of the assembly that we just looked like, which I just showed you. Again, it's not too bad. It's just new, something that you haven't seen. So you can see the different functions that have been pulled out here. Okay, objdump, we looked at the symbol table here, also pretty cool. Okay, powerful stuff. So compilers are pretty neat. we're going to look at some of the information that's taken in and, really just appreciate the job that they do. This job of compilers are really just translators that transform a high-level language like C to binary. Okay, so going from some language, whatever language you want, as long as it can get to binary, that's what the computer can understand. So all of a sudden, C code doesn't look too bad, right? If we just look again at this sort of hello.c, we can sort of work our way through this. This doesn't look too bad. It's certainly better than writing code in ones and zeros. Okay. Okay, so compilers, this sort of picture is going to be a core of this class. Okay, the other pieces that are going to be important, at least on the system side, we'll get to the algorithm side, is the sort of hardware and then the operating system. Okay, so let's take a few minutes just to talk about the hardware. And we're going to talk about, we're going to look at this picture a couple times. It's kind of useful. That the hardware is really the brain of the machine, where the CPU is. In your CPU, maybe you've heard about microprocessors, and Intel makes them, and AMD, and one or the other makes them better, or Qualcomm or ARM, or all these sort of, Apple makes their own now, CPUs. And, really this is just where one instruction is executed at a time, only one in the CPU. Okay, modern CPUs do multiple at a time, but it's really fascinating to think about what that instruction lifetime is, right? When you do one single command, what it goes through, okay? And then we generally measure the speed as megahertz, or today, you're buying a good machine that is in gigahertz. How many, what's the frequency of instructions that you can execute? Okay, and then we'll talk about the different pieces though, because the brain's interesting for the CPU, but if you think about the CPU as a brain, like your own brain, there's different pathways to transfer information back and forth and sort of sensory devices, if you will. But we'll talk about the different, buses that transfer information back and forth from different pieces to the CPU, like memory, for instance. Like how do we store information and get that into the CPU to execute on it? Okay, so that's just a little bit of the hardware, and then we also need to talk about the operating system. Another sort of magic, piece of equipment here. So go ahead and take a moment to pause the video and ask this question: what is an operating system? And hopefully you've taken a moment to pause the video and actually, ponder this question just a little bit about what an operating system is. And I'm be curious to see what you thought about, or if it lined up, or even if you did a quick Google search and sort of learned something. Because typically when I boot up an operating system, and this would be a correct answer, you could say, well, it's Windows, it's Linux, it's a Mac, whatever shows up. There's different operating systems. There's many different operating systems. So you might have come up with something like this. That's what an operating system is. And they're actively developed, so you might go on co-op and actually work on one of these operating systems. We've had Northeastern students do that, or work on open source ones. That's fine. But how we're going to look at an operating system, a little bit deeper dive, because we want to see the magic, is to think about an operating system as something that sits between all the software and the hardware. So here's a little diagram here. Here's you, the user. If you want, we can. I like to pop up on these videos, so I'm going to put the user here, me just really tiny here, just a little video here. The software that you're running, and then the operating system here sits between, this could be Windows or whatever, and the hardware. So it's really trying to figure out how to get the user to talk to some software and be an interface between the hardware, okay? And the operating system really is managing a lot of resources, right? You have a lot of memory, maybe multiple CPUs, and it's got to figure out how to allocate and manage those resources and do so fairly. So the operating system is also a control program. Controls the execution of a lot of user programs. So let me do a little example here. If I run, since I'm on Linux process manager, I have lots of different processes here. You'll notice most of them are Chrome for me, but they're all running, and this is the different processes here. Operating system has to figure out how to run them. And remember, I told you the operating system can only run one thing at a time. Okay. Okay. So here we are again as a user. You could put me here or whatever. Let me get rid of myself. So again, we have maybe multiple users or one user running multiple applications, and the operating system sits in between there. Okay. Okay, so one of the interesting applications that you'll be using throughout this course and for the whole entire course is the command line. Okay, what's the command line? It's also known as the terminal. That's this device that I've occasionally been popping up to write some code in. So you're going to learn how to use it like I am and write stuff in an editor called Vim and make different changes and do fancy things. And it's really going to be an invaluable but practical skill to have. Okay. Here we talked again about the operating system being a resource manager. I showed you the Linux version. Here's the Windows version you might be familiar with every time you hit Control-Alt-Delete, sort of deciding which programs get to your CPU, your memory, and so on. And there's really two main operating system families to talk about. There's sort of the Unix or POSIX family. That would be your Linuxes, BSDs, Mac, Android, iOS, excuse me. And then there's your Windows family, stuff that's shipped by Microsoft. Maybe an Xbox, maybe a Zune device if you remember, a Windows phone when those exist, etc. Microsoft stuff. But there's lots of other operating systems, even operating systems for handheld gaming devices like a Nintendo or something, a Nintendo Switch, a watch, Apple's running some version of iOS on its watch. Your toaster or smart fridge might have a very lightweight operating system. Cars, I'm watching the electronic vehicle space, if anyone's watching that, to see what kind of stuff Tesla's doing and their operating systems and so on. So there's lots of different operating systems in places where you wouldn't really think about it. Anywhere you need a good resource manager. Okay. For this course, we're going to be focusing on Linux. I'm on a Linux machine. It doesn't matter, again, if you have Windows, Linux, or Mac for this course, but you'll be working in a Unix environment. Okay. So the Unix Linux environment for this class. Sort of first the who, what, why Linux. I remember when I started undergrad, they told me I was going to work in an operating system called Solaris, which is Unix based, and I had no idea. Forced myself to sort of use it, and here we are. So what is Linux? It's a free family of operating systems. I use Ubuntu, but Linux was created by this gentleman named Linus Torvalds. And there's been many different other varieties of Linux, and they all operate on roughly the same core, same foundation that they're built on. And that's called the kernel. So the Linux kernel is something that you'll often hear of. So there's, again, different flavors of Linux. You can download your favorite. Most all will be fine for this course. I recommend Ubuntu or just working on the Cori machines at Northeastern, which run on CentOS. This operating system. And generally, as programmers, we like Linux because it's clean, it's very hackable, it's a neat operating system, and it's great, to use in production. Just as many people use it, industry purposes and so on. But when many people think of Unix-like operating systems, they also think of hackers and command line interfaces, so working in the terminal. Okay, so that's what I mentioned before, the terminal or the command line interface. And at its highest level, it's just another program. And Linux and Windows and Mac all have these terminals. And we can execute programs from them. Okay. So I'm going to execute a few alongside here. You'll see some more of these in sort of the canvas, like ls. This is a program that will list the files and directories wherever I am. So ls is a command. Okay. cd is a command for changing the directory. So let me just do a few examples here. So I can see where my current path is. I'm in this folder, home, mic. And let me just go ahead and open that folder for you. So I'm somewhere in here in this folder. This is probably how you're thinking of it. I can make a directory called __ 5008. Let's do that. So then if I look in here, you'll see, oh, there's a new directory here. And I can change directories into 5008. So I'm here. And if I see what that path is, I'm in home mic __ 5008. I can make a new file with a touch command, touch new file, and you'll see the new file up here. But what we really want to do is get used to not having this graphical user interface in front of us. So I'm going to get rid of it and just working instead in the terminal. Okay. And you'll find the terminal is actually faster for you to do a lot of tasks and to work sort of in a more automated fashion because you're entering in commands or programs that you can execute. Okay, so if I can execute this other program tree, this will just show you what the current directory looks like. I can go back, I can hit tree in this other big folder, and you'll see there's lots of files and directories and stuff. I'll stop that with Control-C to pause that, but you sort of get the idea here. Okay, now there's lots of different ways that you can run some of these different commands. So let me show you a few handy ones. Again, pwd shows you where you currently are. ls lists the files. If you forget these commands, you can type man for the manual pages and then the command. And it'll tell you the name of the command and a little help, and then all the different things that you can do with the command. So you can often pass different arguments like ls-l. That'll list all the files again, but this time with more information, like about who created it, when it was created, how big the file is, and so on. One thing that you'll often be doing is changing directories. That's what the cd command stands for. So if I want to, for instance, I'll get rid of myself here, change directory back into that 5008 folder that I created, the __, I can do that. You'll notice my prompt changes. Yours may or may not, but I can do the pwd to indicate that I have again moved. If I want to move back up a directory, I can do ... and then see that I am back in the home mic directory. cd, and I can type in the whole directory name. This is the absolute file path, and I can move to that path. Again, do pwd. As a shortcut, I can do cd and the tilde mark, and that will always move me back into my home directory. It's a nice little shortcut. I can do cd and a minus, and that will move me back to where I was, sort of one backwards. Okay, so these are just a few little things on using this interface here. Again, and you're sort of making this mental model of moving back and forth between terminal and sort of, when you're first learning this, that you used a GUI. But we're going to be working in the terminal in this class, because that's all you need to do C and algorithms and work on systems. Okay, so here's some of those tricks that we did. Okay, now something that's going to save you a lot of time is to just start doing, let me move this back to the home. You can do cd, and then you can just start typing in __, and then there's tab. And that'll autocomplete. So I love when students do that, just to autocomplete, use tab, or the up and the down arrows to see different commands that you have typed in, your sort of history. In fact, there's a command for history, and it'll show you the last commands that you've done. Okay, so if you think there's something that you want to do, chances are there is a way to do it in the terminal because someone has thought of it. So you can always look up more terminal things. And so why I love the command line, it's just simple and sleek, well, I think the command line is simple and sleek. The GUI, looks nice, especially, folks like Apple have done a nice job. But I'd argue, this is a lot faster than the command line. I can pop this open in a second. I don't have to wait for any program to run. I can quickly edit a text file, one of those C programs that we've done here. Here, let me just edit this. I can quickly make changes to this, compile it. I can open multiple windows here. I can have multiple terminals open. And that's just something that takes a long time to do when I'm sort of pointing and clicking around. So we want to be motivated to learn the terminal. In this class, that's all you need, and all that I'm expecting you to use is the terminal. Okay, and many true stories that I can recount of. And especially in today's remote world, but an example, when I was working in a startup, the startup was located in Boston, in California, a place called Oblong Industries, done some cool Hollywood stuff with it. But I had to connect to a machine in California. So my options are fly to California and, work on a machine, or connect to it remotely over a terminal. And as much as I'd love to travel these days, actually, it's a lot more faster and economical if I can just quickly remotely log in through a terminal, edit a file, and then make those saved changes, run that program from Boston, from home, and then not have to pay for a plane ticket and fly hours and hours somewhere else. So these are real skills. These are pragmatic things. Sometimes you work on machines that don't have monitors even, so you have to remotely connect to them. So just some more reasons to learn the terminal. I know it's going to be a lot to start, but force yourself to use it, and it'll work out. That you can sort of learn these things. Okay, so some other cool things, as I mentioned, we can start automating things. So here's an example shell script. Let me just write it here as example.sh. And you can write some bash shell scripts. So bash is another language, but really all it is hello, let me list the files and folders. Is just a listing, sort of line by line of different commands that you want to execute. Okay, so let me split this window just so you can see the file that we typed in here. So there you see it here. So hello, and then I can execute this file here that I called example.sh. And what did it do? Well, it listed all the files here. And did it print our little welcome message? Yeah, it listed hello, let me list the files and folders, and then it listed all of them. Okay, so you can write these real simple shell scripts here. I've got another example here. Sure, let's go ahead and do it. Where I can read in a value, my age. Let's see, echo, how old are you? You might want to do something like this. And then say, echo, that is great. You are my age here, years old, or whatever the message is that you want to do. So let's actually execute this, make sure I didn't make any silly mistakes here. But Bash is another language that's been around for a long time and allows us to write these little shell scripts here. Hello, how old are you? Well, I'm 500. Okay, so that's great that I am that many years old. Oops, it didn't run here. Let me fix the mistake by popping up in my editor, reading my age. And oops, I should have used the double quotes here if I have a variable embedded here. So let's go ahead and run that again. I'm hitting Control L to clear my terminal. Let's say now I'm 560. I've aged more. So that's great that you're 560 or whatever. So you get the idea. You can automate some of these tasks. Again, that's just another power of using the terminal, right? If there are tasks that you constantly have to do, you can save yourself some time by writing these little scripts that'll do a bunch of things on the terminal for you. That's something that's a lot harder to do on the graphical user interface. And by now you've noticed I've been writing these scripts in a text editor called Vim, and you'll be learning that. You can use whatever you want. You don't have to use Vim necessarily, but you do need to use something that's terminal-based. So again, if you have to, as I mentioned, if you have to fly to, California or Alaska or Australia or whatever, place that's very far from where you currently are, and sometimes that's from your house to Northeastern because it's snowy or raining or whatever. You don't want to go outside. It's nice to have that skill of being able to remote in, edit some text, and run some new code. Okay, so you're going to be learning about Vim in this course. So again, this is something I frequently do, have always done, and honestly prefer to do it. You might find this is your preferred text editor. Okay, so you saw me run that script or a variant of it. You can type this in and practice it and take a moment to execute this video. So please do take a moment to try to find where your terminal is, open it up and see if you can enter some of the commands that I've done. That's another great way to follow along with these lectures, is to actually do as I do. Whether they're for this portion or for the Canvas lessons that you're watching, really do follow along. Again, hands-on course. Okay, so hopefully you had a chance to enter that script. say what your name is. In this case, we're passing in some arguments into this script. That's what the 1 and the 2 are, and then proceed. Now, we're going to be running all of our programs, again, because we want to sort of model that example, remotely on the Cori servers. Okay, so that's at Northeastern. So let me go ahead and open up and show you how to do this. This is with a program called SSH. So SSH, what is that? So I can use the manual page to look. And well, this is it's probably gibberish to us, but it's a remote login program. So this allows us to connect. So SSH is a program for logging into a remote machine and for executing commands on a remote machine. So we're going to log into some other machine here. I'm going to make this window just a little bit smaller so you can see what I'm typing as well as the text here if you're following along. So what we're going to be doing is SSHing. That's sort of the action that we're doing into Cori. And maybe you've done this before, but you have your Cori username here, and then you're going to do @login.cori.nu.edu. So this is your username, this first part, and then this is the machine that you're connecting to. And if that works, it's going to ask you for your password, which you'll secretly type in. It won't echo back, but it will log you in to your machine. And it might ask you, it might give you a yes or no message about, is it safe? Yeah, we can trust that Northeastern's safe to connect to. So if this works, you'll notice that my prompt has changed. This means I'm working on another machine somewhere else in the world in Cori is where I am. Okay, so now I'm successfully executing those commands. So if I do ls here, it might be hard for you to remember what was in my directory, but this is a totally different file path I was working on. In fact, if I scroll up here, let me try to show you something different. There's a bunch of C files in here and different course repositories I have, but you can just believe me that I'm working on a different machine here. So that's how we could say. Okay, so once we've done this, again, once you've SSH'd, you're somewhere else in the world. Okay, and then when you're done with that machine, you just type in the prompt, exit, and you'll leave that machine. So connection to that machine in Northeastern and the server login.cori.nu.edu has been closed. Okay. So again, if you're feeling overwhelmed or like this is a lot of commands, well, again, you have everything on the video, but you have the built-in manual pages. Again, man pages, man is short for manual, but you can type this in and usually get help with almost any command that you can think of. Okay, so the work environment for this course. Two things about that. First, let me remind you to just watch the logistics video, which will cover sort of how to get started in this course there. But let's go ahead and look at what I have here. Again, SSH is what you'll be using. And I recommend using some sort of terminal. If you have a Windows operating system, you can download Linux on Windows. Part of one of your assignments will be installing something called VirtualBox, which sets up a Linux environment. This is an application that emulates a different operating system. So for example, if you're on a Windows machine, you can install a Mac VirtualBox and have Mac within it. We're going to want to install Linux though, just so you can follow along and always have a machine that works on your laptop, regardless if you have an internet connection or not, okay? So here's an example just in VirtualBox of what's going on. Here's my Windows machine. You can look at the bottom left corner. I've got Windows here running with several different applications. And if I launch VirtualBox, this other program, you'll notice in this box here, I have a whole other operating system running within another operating system, which is pretty cool. And I get that Linux environment in a sense for free by doing that. Okay, and within VirtualBox or Linux, so I'm on a Linux machine, so I can just type in terminal and find my terminal here. Okay, you can probably do the same thing on Mac, for instance, and work within a terminal there, and then by SSHing into Cori. So we're always going to SSH into login let me just put in, your username at login.cori.nu.edu. You'll always do this for the exercises, assignments, and so on in this course. Okay, there's a little nice shortcut too, Control-Alt-T, that you'll see me use to quickly pop up terminals. Okay, and now you can run those commands in practice. Okay, so let's go ahead and take a moment to have a fun sort of feed here, in the sense of I want you to be able to just look at some system stuff, and this is something that we can talk about. Steve Jobs and the megahertz myth. So hopefully you've taken a moment or two to watch this video, and we'll discuss a little bit more in the live session what your thoughts were here. Okay, but really it's exposing, a major theme in this class of trade-offs that we're going to understand with our algorithms and systems. Okay, so before we proceed further, I want to make sure everyone, by the time you're watching this video, if you haven't already, is you've gone onto my homepage and on our course website and clicked to accept the monorepo site. Again, this is covered in the logistics video here, but what I want you clicking on is this course repo here, so you can actually start downloading the assignments and the labs and just be ready to go there. Okay, so please click on that at this moment. That'll give you the GitHub repo for this class. You can use your own private GitHub account, and that's where the instructors and course staff will push assignments and labs so that you're ready to go. Okay, and we are online. Obviously, if you're watching this, you can pause whenever you want and take a break whenever you want, but this is just a reminder to do so every once in a while. And give yourself some time to go back a few slides, try some of the examples, and so on. And then come back refreshed and ready to learn for this next part. Okay, so if you're joining back after a pause or just powering through, whatever you've chosen, let's go ahead and talk a little bit about C. The C programming language, in short, can be said, for infrastructure technology, C will be hard to displace. And this is from a gentleman named Dennis Ritchie. And Ritchie, who was he? Well, we should take his advice. He's the co-creator of the C programming language, along with Ken Thompson at Bell Labs. So he wrote the C programming language book, which is recommended with this course. It was written quite a long time ago, but it's still the best resource. Go figure. The guy who wrote the book knows what he's talking about. So this is a great resource. But Dennis also worked on the Unix operating system as well. Okay, and for our Boston-based folks, he's a Harvard graduate, so he's just across the river, near Northeastern. And he's a Turing Award winner, which is the highest honor you can win in computer science. It's the equivalent of a Nobel Prize, so it's pretty prestigious, pretty cool, and he's a pretty humble guy. Okay, so what do I say about that? Well, for infrastructure technology, C will be hard to displace. I foresee C programming jobs for a long time. So that's a good thing for us, again, because we're learning C programming in this course. Okay, so introduction to C, C is going to be our tool for creating systems and algorithms. Okay, a little bit about C, the language. Well, it's successor to a language called B. Not very original. It's kind of supposed to be funny that they did that. It's considered a high-level language. It's a systems programming language compared to assembly. It's strongly typed, meaning we're gonna, type the data and mean what the data actually is. We have to manage our own memory, something you probably weren't doing in Python or used to doing. We're gonna have control over those resources. We can dive into assembly, and it's also very highly portable. So once you learn C, you can use it on, Mac, Windows, Linux, PlayStation, Nintendo, whatever language or whatever platform you need. Okay. So let me give you the crash course before we sort of jump into lab where we get to practice some of these things. But here's a simple C program, right? We wrote our hello world, and we can compile it with the GCC compiler here. Here's the basics. And then this feeds this source code into the compiler and outputs the binary, right, when we do the GCC. So we talked a little bit about that. So here's the sort of basic C program. Scope, it's a scoped language. In other languages like Python, you use tabs, to sort of identify the scope. In C, we use the curly braces, okay, to sort of identify the scope of something. So if you have, say, declared this variable, this x here as an integer, and so it's 5, so it can hold integer types, -27, things without decimals, that's what it can hold. But this x only lives within these two curly braces here. Okay, so if we can create a new variable with that same name as long as it's not in the same scope here. Here's a simple function in C, an add function. So it's created before we need to use it or call that function, which we call it here. We do printf. It'll call this function add 2 and 3. So it takes in those parameters 2 and 3, returns 2 plus 3 here. The value 5, and then in the printf function, it replaces where this %d is. That's a sort of placeholder for a digit or an integer, the result of this, 5. In C, we have the same control flow that we have in other languages, like Python, for instance. You have if conditionals, if else. You have for loops here, where you create a variable, set its initial value to 0, say, well, x is less than 10. It'll add x plus 1. There's other while loops, less than, greater than, and with double ampersand, or with two pipes to do these different conditional statements. Here's an example with a while loop. We're going to have main and do a little countdown. And I'd recommend, again, typing in all these programs and compiling them on the command line. Okay, and then here's just another function that can return an integer value here, like we looked at before. So this time, what's different about this example, I'll just highlight, is that we're storing the value of this function into an integer and then using it. And then we have arrays. So this is our first data structure where we can store information. It's sort of a similar idea to lists in Python, in that we can store a bunch of data rather than having to create lots of variables. So here's my favorite numbers. It's an array that can hold 3 values. In C, it's a 0-based language, so 0, 1, and 2 here, where we store each of our favorite numbers here. The type for all of these things in the array must be the same, so they're all integers. Okay. So a few other observations and notes about C programs. If you take a moment to, again, pause the video and try to type these into an editor. As part of your lab, you'll be able to type these into an online editor, but we really want to get used to doing these on the terminal. But notice the indentation's nice. We've tabbed over every time we have a curly brace, so it's nice and easy to read and see the scope of things. And then just notice that things like if, while, and for, those are sort of keywords in the language, but they're statements that have to do with the conditional flow. So they don't end in semicolons, but everything else does end in a semicolon to sort of terminate this statement here. Okay, so at this point, please complete the in-class activity, or remember to do so before the next module is released. Where those are, again, if you go to Module 1, begin the module, and then down to in-class activity, you click this link and you'll be good to go. Okay. So this sort of finishes the in-class activity portion of the class, and then we move to the lab portion. Okay. So how lab works, some labs will be done in teams, some done individually, and since we're online, a lot more wind up being done sort of individually. At least you're responsible for mostly. And then if we get back to in person somehow, myself and other course assistants will walk around and help folks. Otherwise, we're just going to be doing that online during the live session. We'll have time for questions and sort of working as a large group and then sort of breaking out. But the idea is the rest of the live session time will be sort of working in the lab and answering questions. So again, make sure you acquired the monorepo. Make sure you clicked exactly on, let me go back here, this link to get the repo here, course repo right here. Please click that link. And then you'll get the link. And we've talked about that. And then we've also talked about SSHing into the Cori servers. Once you've done that, you'll want to clone your repository. If you're not sure how to do that and how to get your repo, please watch the logistics video. That'll show you how to do it and how to make a change, okay? And how to see if that change has been made by looking at it on github.com, okay? So here's just a little bit about GitHub, but that's not covered on the logistics video, so you can watch there. If you have questions on GitHub or maybe forgot, there's lots of resources here. There's a few on this module page, as well as in the Canvas page. So you're going to watch those videos too and see how to set up GitHub. Okay. Okay. Just a note on Cori SSH, just be careful if you log in too many times. If you think you forgot your password, I can't reset it. So you have to email systems at Northeastern, or rather systems at cori.northeastern.neu to get that password reset. Okay, so this lecture in summary, we learned a lot about computer algorithms and systems, or we're going to. We're going to be working in the C language. We're going to be working in the terminal and Unix environments, learning lots of command lines. We're going to be SSHing and working on the Cori machines, and then pushing our work to a private GitHub repository. And then also you understand how this course works and have got introduced to me. Okay, so that's it. There's a few bonus slides if you just want to see sort of from C to Python or Python to C, if that's helpful. At the end here, you can take a look at that if that's useful. So that's it for me. Let me go ahead and show you one more time. You will find, again, all these videos will be posted here, usually a day before the module, so you can watch the video. And then your next step is to go onto the Canvas page and then click on the module 1 here and begin watching those videos. So there'll be more videos. Again, some of it on just diving into C programming, for instance, understanding some GitHub stuff and getting some more help. Okay, so we will be in touch again very, very soon. For my section, again, Thursdays 1:35 to about 4 or so, we'll have a live session where we'll recap this material, go over things in lab, and any other questions you have. All right. That's it, folks. Talk to you soon.